Imagine a solid object. That doesn't stay solid. A surface that can change shape on command. A material that can reconfigure itself into something completely different. That's the idea behind programmable matter. Instead of building objects with fixed shapes and functions, engineers are experimenting with systems that can physically transform based on instructions. Not digitally, physically. The concept sounds simple, but the execution is where things get strange. Most approaches to programmable matter involve breaking materials into smaller units, tiny components that can move, connect, and rearrange themselves. Think of them like microscopic building blocks. Each unit has to do three things: move, communicate, and connect with other units. Now imagine millions of them working together. That's where the problem starts. Because coordinating that many moving parts isn't just difficult, it becomes chaotic. Each unit needs power. Each unit needs to know where it is, and each unit needs to respond to instructions without crashing into everything around it. This is where things shift from engineering to control theory. You're no longer just building a material, you're building a system that behaves like a swarm. And swarms don't always behave the way you expect. Now here's the wait, what moment. At a certain scale, the material stops acting like a solid object and starts acting like a programmable system, which means the object you're looking at isn't really an object anymore. It's a temporary arrangement that could change, collapse, or rebuild itself into something else. A tool, a structure, even a completely different shape. But physics still shows up. Movement requires energy. Connections require force. And scaling the system up introduces serious limits. The more units you add, the more complex coordination becomes, the more power you need, and the more chances there are for failure. If enough units lose synchronization, the entire structure could break down. So the challenge isn't just making matter programmable, it's keeping it stable while it changes. Engineers are experimenting with different approaches. Some systems use magnetic connections, others use mechanical locking structures. Some rely on external control systems. Others try to distribute intelligence across the material itself. But all of them face the same problem. How do you control something made of thousands or millions of moving parts without losing control entirely? Programmable matter isn't fully realized yet, but the direction is clear. Materials that don't just exist, they respond, they adapt, they transform, and if this technology ever scales successfully, the idea of fixed objects might start to feel outdated. Because in a world where matter can be programmed, nothing is truly permanent.